The second question is a very nice question. It comes from the concept of 2Ds and 3Ds, the application of the sine, cosine, and the area rule, right? Solutions of random triangles. We are given a diagram. It says to us here, in the figure below, acute angled triangle ABC is drawn having C at the origin. Now, first question says you need to prove that C squared equals to A squared plus B squared minus 2AB cos of C. All right. So what do you see here? What is going on is they want you to prove the cosine rule. You guys should know there's area rule, cosine rule, and the sine rule. As a grade 12 or even a grade 11 learner, you are not limited to proving geometry theorems. You are sometimes required to learn how to prove the sine rule, the cosine rule, and the area rule. So remember to also practice those. This is by far the most complicated of the 3 rules that we get in trigonometry. So now how do you actually work with this? I'm going to use the distance formula to prove the cosine rule. Just keep that in mind. The proof of the cosine rule is done using the distance formula that we get from analytical geometry. That's what you're going to use in order to prove this. But what does the distance formula say? Well, we want to prove what C squared is. First of all, let's label all our sides. Remember, the side opposite angle A is known as small a. The side opposite angle, that small c is opposite angle C. Opposite A will be small a, and opposite angle B will be small b. So those are the lengths of the sides opposite to those angles, okay? So we want to find this proof in terms of C. So which means we are interested in this line here. We want to find the length of AB. Now, if I do that, how does the distance formula assist? It will say to you AB squared equals, right? AB squared equals to x at B minus x at A squared plus y at B minus y at A squared. This is very simple. Everybody understands the distance formula. It's what you people call x2 minus x1, y2 minus y1. The difference between the x's and the difference between the y's. Now, if you are going to calculate the distance between 2 points, you obviously need the coordinates of the first point and the coordinates of the second point. So once we've got that, the rest is just simplification. The algebra and the trig will kick in, and then you'll be able to prove your cosine rule. But what is important is you need the distance formula. So you need coordinates. Let's find them. All right. Now, the easier one is point A at the bottom. See point A there at the bottom? We can find the coordinates of point A. Remember, point will have an x and a y coordinate. A is on the x-axis. That means y is 0. Now, the distance from the origin all the way to A is b units, according to our calibration here. We said the side opposite angle B is small b. So the length from C to A is actually b units. That's why my x-coordinate for A is small b. Now, the problem is on the coordinate of capital B there, right? This is basically what I'm going to work with. So I want you to pay attention to something very important. If I've got that diagram and I redraw it, right, and I'm interested in finding the coordinates of B, which means I want to know what is x here, I want to know what is y here. I'll draw a height here. Let's construct a height because B is exactly above that white dotted line that is perpendicular to the x-axis, okay? So I want to find out the x distance from the origin, okay? And I also want to find the y distance from the origin because those will give me the x-coordinate and the y-coordinate at point B. The angle that we were given on the origin is C, so it means this angle is C. So I'm going to now use my trigonometry to find what x is and what y is. And I think we also remember that this hypotenuse in the right angle triangle I just created now is small a from our labeling on our diagram. That's small a because it is opposite angle A in the original drawing. Okay, so hypotenuse here is small a. I'm looking at the red grade 12s. This is a right angle triangle that I'm looking at. Okay, it's going to help me to find the coordinates of B. Right, so what did we say? That's opposite side. So if I want to find x, I'm looking for the adjacent side. So I can just simply say cos of angle C is adjacent, which is x over hypotenuse. And then if I simplify that by making x the subject of the formula, it's going to just simplify to x equals to a cos of angle C. And that is the x coordinate of point B. It is just small a cos of angle C. If I want to find the y coordinate, I'm now going to need to use sine because that's opposite over hypotenuse. So I'm going to say sine of angle C is the opposite side, which is y, divided by the hypotenuse, which is small a. Okay? And then if you simplify that, your y comes out as a sine of angle C, which gives us the y coordinate of point B. Okay? So let's put that. It's going to be a sine of angle C. So those are the coordinates of B. I've got the coordinates of B. I've got the coordinates of A. I can just put them here. Okay, this is a cos of angle C. This one is a sine of angle C. Now I'm going to apply my distance formula. From here on, it's just very simple. So x2 minus x1 squared, y2 minus y1 squared. So the substitution, my x at B is small a cos of angle C. Minus comes back, there's my minus. X at A is small b squared. Plus y at B is a sine of angle C minus y at A is 0 squared. All right? Now there comes our binomial squared again. How do you square binomial? You square the first term first. So you're going to have to square this because we need to apply something minus something else squared. Two terms squared, that's squaring a binomial. So you square the first guy, you get a squared cos squared of angle C. Then you multiply the 2 and double them, right? You multiply the 2 and double. So it's going to be minus 2ab cos of angle C, okay? And then you square the last guy now. You're now going to square the last guy, who is b. So when you square b, you're going to get plus b squared. And then plus, we have to go to the second bracket. The second bracket is a sine C minus 0. That's just as good as a sine C. If you square that, you end up, if you're squaring this portion here, you end up with exactly a squared sine squared angle C. All right. So now I've done all that I've done. All I need to do is group the like terms and then simplify from there. If any trig facts come up, I need to deal with it as I meet them. Right. Important thing, you just break the brackets, simple algebra, and then group the like terms and then simplify from there. Okay, so let's identify like terms. You will agree with me that this guy is friends with this guy. Why? Because both of them, they've got a squared on them. Okay, so which means I can factor out an a squared out of them. So I'll get a squared into cos squared angle C plus sine squared angle C. Okay, then there's this b here. I'm putting it next, plus b squared. And then there's this minus 2ab. There's minus 2ab cosine of angle C. Okay, awesome stuff. Now, in the brackets, you guys will see that we've got something squared plus something else squared. Sine squared plus cos squared of the same angle. That amounts to 1. So this leaves us with a squared. And then that b squared comes back again. B squared minus 2ab cos of angle C. And that is what small c squared is, since small c is actually the length of that AB that we were looking for, which is the side opposite to angle C. And that gives us the solution to this question. Very, very nice, not difficult. It's important for you to understand when you have to prove these rules. You can even check in your textbooks. Make sure that you understand what they are doing. Don't try to memorize all the steps. You will never get it. See the math that is being used. Here, they're using the distance formula. If you know how to work with the distance formula, the math should naturally come out when you're working with this. The closing question, sub-question of this question is asking us for something that looks very terrible. They say now, hence deduce that 1 plus cos C, okay, equals to a plus b plus c into a plus b minus c over 2ab. Okay, all right, that's the second question. All right, now we have to deduce that 1 plus the cosine of angle C is a plus b plus c into a plus b minus c, everything divided by 2ab. Okay, we need to prove this. But they say we need to deduce this. So you can't use what you need to deduce. You need to use something else, and it must help you to eventually lead you to where you have to end up. So we have to prove this. We need to prove this. We can't use what we have to prove. Okay? So I'm going to take the cosine rule that we just proved in question 1, which started as follows. So c squared is a squared plus b squared minus 2ab cos of angle C. So from here, I must be able to work my way towards this, which is what the examiner is asking us to deduce, right? Now let's try and make them look the same. First of all, you will notice that the cos C is on the left-hand side of the equation. So I'm going to have to add 2ab cos C on both sides, which is as good as saying moving that side, okay? We don't transpose stuff, we're adding it on both sides of the equation. All right, when I do that, then I'm going to have positive 2ab cos of angle C equals to a squared plus b squared minus c squared. When I move this c to the right-hand side, it becomes a minus. All right? Now, this looks like it has the potential of the difference of two squares. The only problem that it's not the difference of two squares is the fact that my a squared and my b squared is not really a perfect square at the present moment. But if you are familiar with the concept of squaring a binomial, you'll agree with me that if I want it to be that, then it means it will be a squared plus 2ab plus b squared. So we already have in our equation this part. We already also have this part. I want to make it a square because it has the potential of being the difference of two squares, which is what I see when I look on the numerator of what I need to see, or I need to work with here. It looks like x minus y into x plus y, and that only comes from x squared minus y squared. It has the potential of being the difference of two squares. So I'm going to force it to go in that direction. So what I'm sitting with has got a squared and b squared. I'm missing one thing. So this is the only thing that we don't have. This is what is missing, okay? So because it's missing and we need it, we're going to put it here. I'm going to add it. So I'll say on this a squared, I want to add 2ab, and then I've got b squared minus c squared. But mathematically, that will be wrong, because if you add something on one side, you'll need to also add it on the other side. So I add 2ab on both sides of my equation, okay? There's nothing special about what I did. I just tried to introduce something that was not there. This guy has been added on the left. The same guy has been added on the right-hand side, on both sides of the equation. I'm still sitting with what I had on the numerator. The idea behind what we are doing here is we're forcing this question to be a perfect square, because that factorizes to what I'm currently sitting with. And on the left-hand side, good news, 2ab becomes a common factor. You factor it out, it leaves you with a 1 plus cos of angle C. Now that I'm here on the right-hand side, I'm going to apply my difference of two squares. When you're factorizing difference of two squares, it always 2 bracket. I call it dots, okay? Then it's going to be the first guy, which is a plus b, plus the second guy, times the a plus b minus the second guy. That's the factorization, okay? And then if I divide both sides by 2ab from the first bracket on the far left, that leaves me on the left-hand side with 1 plus the cosine of angle C, which is exactly what they wanted us to deduce without any challenges.